All right, today we're diving into something that sounds a little wild. A mind-bending connection between two fields that honestly couldn't seem more different. We're talking about the fundamental laws of physics and the patterns of our economy. It sounds like a riddle, doesn't it? What on earth could a simple spinning wheel possibly have in common with the incredibly complex up and down movements of the stock market? Well, the answer reveals a surprisingly deep pattern that, it turns out, governs both. So, to start unraveling that riddle, we've got to go back to basics. We need to start with the building blocks of classical physics. And it turns out a whole lot of the physical world can be described by just two fundamental types of motion. Okay, so on one hand, you've got translation. Just think of an object moving from one point to another in a straight line, kind of like a block sliding across a cable. Simple enough. On the other hand, you have rotation, an object spinning around a central point like a wheel or a gear. These two simple ideas, just moving and spinning, they are the absolute key to unlocking this whole economic analogy. So keep them in your back pocket. Okay, now let's take that first type of motion, translation, and see how it applies to the world of economics. We're going to start with the most basic economic activity there is, just trading simple stuff, commodities. Now, to really get how economists think about these simple commodities, we actually have to borrow one more really important idea from physics. It's this core assumption that space is homogeneous. Now that sounds fancy, but all it really means is that the laws of physics are the same everywhere. An experiment you do over here in the lab works the exact same way as it does on the other side of the lab. The rules don't change just because you moved.
And this symmetry, this idea that the rules don't change no matter where you are, it has a really powerful consequence. It gives rise to what physicists call a conserved quantity. In this case, for translational symmetry, that conserved quantity is momentum. It's the reason a billiard ball keeps rolling until it smacks into something else. Its momentum is conserved because the laws of physics are the same all over the table.
So, how does this link back to economics? Well, classical economic theory makes a very similar assumption when it's talking about simple things like apples. The theory basically assumes that the laws of supply and demand are independent of what happened in the past. Your desire for an apple today isn't fundamentally different just because millions of apples were sold yesterday. The economic space for that one transaction is always the same.
And you guessed it, just like in physics, this symmetry in the economic model gives us a conserved quantity. And for simple commodities, that conserved quantity is price. The whole idea of a stable, equilibrium price for apples even exists because the model assumes every transaction is independent of the last one. Price is basically the economic equivalent of momentum.
So, the simple back-and-forth trading of commodities, that's our economic version of translation. But, modern economics is so much more complex than that. So now, let's introduce our second type of motion, rotation, by bringing in the concept of capital. And here is the crucial twist. Capital. We're talking about things like a factory, a piece of land, or even financial assets. It just doesn't behave like a simple commodity. It's not a one-and-done transaction. It has a fundamentally different dynamic, one that looks a lot less like a straight line and a whole lot more like a rotation. Let's break that down. Think about that rotation again. You need a fixed center point. In economics, let's call that the firm, or the owner. Then you need a fixed radius. Well, that's the capital itself, the land or the machines, which stays pretty constant. And then you have the rotation itself. This represents the return on that capital, like the crops you get from the land, or the profit the factory generates year after year. Okay, so we've established these two parallel tracks, right? Translation and rotation in physics, and commodities and capital in economics. Now it's time to bring them together with this really profound principle that basically unifies both worlds. This right here is the core idea, sometimes called Noether's theorem. What it says is that for every symmetry you find in a system, for every way you can change it without actually changing the fundamental rules, there's a corresponding quantity that is conserved, or stays the same. And this isn't just a rule of physics, it's a fundamental law of how systems work, and that includes our economic models. And this table just lays the whole analogy out perfectly. Symmetry under translation in space gives us conserved momentum in physics, and that corresponds to a stable price in commodity economics. Symmetry under rotation, which in physics gives us conserved angular momentum, the tendency of a spinning top to keep spinning, well, that corresponds to the return on capital in economics. And finally, what if the laws are the same over time? In physics, that gives us the conservation of energy. The economic equivalent?
surplus, or what we call profit. It's a complete unified framework. It's pretty amazing.
But look, this isn't just some neat, abstract theory to talk about. This distinction between a translational and a rotational view of economics has had a massive, tangible impact on the entire course of human history. No, seriously, this shift from a purely translational, commodity-based view of the world to a rotational, capital-based one is arguably one of the most important transformations in the entire history of civilization.
Think about it. For most of human history, we lived in hunter-gatherer societies, a purely translational economy. You find some berries, you eat the berries. It's a direct one-to-one exchange. But then, around 8000 BC, the agricultural revolution happened, and it ignited the rotational economy. And when it did, it changed absolutely everything.
So, what happened when we made this huge shift? Well, all of a sudden, land became valuable, fixed capital. This new way of farming created a surplus of food, which meant that not everybody had to spend all day just trying to find their next meal. And that surplus supported brand new non-farming classes, people like warriors who were needed to defend that valuable land, and priests. And this, in turn, led to the birth of specialization, to markets, and, really, to the field of economics itself.
So the next time you look at the economy, doesn't matter if it's a simple purchase you're making or the huge, vast world of finance, ask yourself, are you just seeing a simple, straight-line transaction, or are you actually witnessing the powerful, world-changing spin of capital at work? It's a question that connects the atom to the apple and the spinning wheel to the stock market. Thanks for watching.